Hello, my name is Untitled Chapter. I am a field application engineer from Untitled Chapter. Recently, we released our second generation of medium voltage MOSFETs, which are generally defined as MOSFET with 60 volt to 200 volt drain voltage.
One of the popular applications is a point-of-load regulator which uses DC to DC buck converter topology, in which medium voltage MOSFETs are widely used. We have released an application note AN-PJ1004 with the title Lossless Distribution Analysis of a Synchronous buck converter with 100 volt MOSFET. The audience will get general information about power loss analysis of a synchronous buck converter. In this application note, we discussed about the synchronous buck converter evaluation board, which was specifically designed for power loss distribution characterization under continuous operation. The schematic of the buck converter circuit is shown on this picture. Pungent medium voltage MOSFETs can be used as high side and low side switches as indicated by the red side. We use pungent MOSFET with part number PSMQC040N10NS2, which is 100 volt 4 million MOSFET with field gate technology. Generally, customers want to use lower RDS(on) MOSFET for low side and low capacitance MOSFET at the position of high side switch. We, however, use the same MOSFET to show the power loss analysis more easily. The picture shown on your screen shows PCB design where drain current, drain voltage and inductor losses are measured. Calculation of losses analysis is explained in detail in the application note to help reader to understand methodology used. You can see pungent medium voltage MOSFETs with DFN 5x6mm package which are used for low side and high side switches. This is equivalent schematic of the current measurement. We use low inductance shunt resistor having parasitic inductance below 0.2 nH. Signal goes through the RC filter to compensate for the shunt resistor parasitic inductance and shielded cable. We are using 50 ohm cable to connect with the scope with 50 ohm input impedance. Probe connection to the PCB is made with very short wire to reduce parasitic components on the probe side. We are using current probe and passive voltage probe to measure inductor current and voltage. We obtain various waveforms such as MOSFET drain source voltage and drain current and inductor current and voltage. These measurements are used to calculate the losses distribution. Drain source voltage and inductor voltage are shown in black color while currents are shown in red. Based on the current and voltage of the MOSFET, we can get a switching loss and conduction loss of the MOSFET. Based on the measurement of voltage and current on the inductor, we can obtain power loss of the inductor and use this data for analysis of the system efficiency. This graph shows measured system efficiency according to output power. We can easily measure it with some equipment, however, it needs more effort to tear down the power losses to see more detailed information about the power loss distribution of the buck converter system. In the previous chapter, we measured each current and voltage to see the power losses in detail. As you can see in this graph, most of power loss come from power MOSFETs and capacitor. So, if you want to get higher efficiency, it is critical point to choose proper components based on the power loss analysis. This graph shows each part of the power loss according to output power. You can see the power loss with pungent MOSFET PSMQC040N10NS2, which shows quite good result. Thank you for listening and do not forget to download our application note AN-PJ1004. For further information about the application note or our product lineup, feel free to send email to sales@pungit.com.tw.